Everything in our world is composed of matter, and today we will discuss how scientists classify ordinary matter in terms of phases and composition. We're all familiar with the idea that ordinary matter can be classified as solid, liquid, or gas. Solids are composed of densely packed atoms or molecules that are held together rigidly by strong intermolecular forces. So on a macroscopic level, solids have their own definite shape and volume, independent of the shape of a container that may hold them. Liquids are also composed of densely packed atoms or molecules, but the forces between them are weaker, so they move around and slide against one another. As a result, a liquid will partially adopt the shape of its container, but like solids, liquids have a definite volume, so the unfilled portion of the container is separated from the liquid by its surface. Gases, on the other hand, have very weak intermolecular forces, so the atoms or molecules are separated from each other. They fly around, filling the entire volume of the container uniformly. Gas pressure results from collisions of the molecules with each other and with the walls of the container. We can also classify matter and materials by their composition. We start by defining matter as anything that has mass. In our everyday world, that's everything we can see, touch, hear, taste, or smell. Everything except photons, or light, which consists of electromagnetic radiation. One type of matter is pure substances, which have fixed composition and definite physical properties, like melting point or density. Some pure substances are elements, which are composed of only one type of atom. Notice that oxygen and ozone have different numbers of oxygen atoms in their molecules, but both are classified as elements because they contain only oxygen atoms. Pure substances can also be compounds composed of molecules made up of different types of atoms, but in definite proportions. For example, water is composed of hydrogen atoms and oxygen atoms, but always in a 2-to-1 ratio. If a substance is not pure, then it must be a mixture of some type. Mixtures can be separated by physical processes like filtering or distillation that don't involve breaking or making new chemical bonds between molecules. A homogeneous mixture has uniform properties throughout the sample. It consists of a single phase, but could be a solid, liquid, or gas. Because homogeneous solids are uniform down to a microscopic level, they are almost always clear in appearance, but they might have some color. Heterogeneous mixtures, on the other hand, have properties that vary throughout the sample, and they may be composed of 2 or more phases. Examples are foam, smoke, creams, or aerosols. Now we are prepared to discuss phases in more detail, including melting, vaporization, and other types of phase changes. We are also prepared to talk about how to measure concentrations of mixtures and how to prepare new solutions of chemical compounds at specific known concentrations. I'm Chuck White, and I'll see you here again soon.